Class, welcome to the next part of Chapter 2. Today we are going to focus on graphing, understanding shapes of graphs, as well as performing rigid transformations. So I'll explain that in a second. Before we get to that, though, I want you guys to really study this first page of notes. All right, we drew graphs in for you with examples. These are not going to go away. All right, these are graphs that you should know from Algebra 2 class. However, we know we had a delay, things go away, we need to reintroduce this, okay? So there's all of these different types of functions, and we need to remember them, okay? Today, for today, we're not going to focus a ton on very exact points and more just the shape. So I will go through these a little bit in detail, and again, we'll dive really far into these in the coming days. So, square root function, right? F of x is equal to the square root of x. Square root, we see a square root, so it's the square root function. Really what we're looking at here is it's going to usually start at the origin, and then it's going to kind of shoot up and out to the right. We could, if we wanted to, we could get exact points based on plugging in perfect square numbers, right? If we plug in a perfect square of 1, we know that the output would be 1, so it would be over 1 up 1. Well, if we input a 4, we know we would go up 2, so over 4 up 2. We could keep going, 9, 3, 16, 4, 25, 5, and so on and so on. That's what gives it its shape. Now the cube root function is similar, however, we notice what? This has two sides, right? It doesn't just start at the origin, or maybe we could say it starts at the origin, but it goes in both directions. The square root one, we cannot go back, right? We can't plug in negative values. We can't take the square root of a negative. So that's why it has to start at the origin. Cube root is a little different. When we plug in plug in perfect cubes, such as 1 again, well, that's 1. Well, what's my next perfect cube? How about 8? So 1, 2, 3, 4, 5, 6, 7, 8, up 2, because the cube root of 8 is 2. It works going backwards, though, too, right? You can plug in negative 1, and the cube root of negative 1 is negative 1, or the cube root of negative 8 is negative 2. So that's, again, kind of why these two work the way they do. Absolute value is really nice. Hopefully we remember absolute value is basically just taking the positive value of whatever the input is. So the right side is nice and easy, right? If I go 1, like if I plug in a 1, well, it's 1. If I plug in a 2 and I take the absolute value, it's 2. Or 3, 3, 4, 4. Going to the left, however, you have to remember that if you plug in a negative 1, you have to change it to positive. So that's why it's negative 1, 1. Or negative 2, positive 2. Negative 3, positive 3, etc. As we move on to the next row, we have a constant. Constant is just a horizontal line, right? We know this. F of x equals b, or we could also write y equals b, and that is just a horizontal line with a slope of 0. This next one in the middle, the identity function, we give it this name because it's basically saying y equals x, or we know that y is going to be equal to itself, right? If we plug in a 1, well then y is 1. Or if we plug in negative 5, y is negative 5. So the y and the x value are completely the same, which gives us this nice graph, y equals x. The next one, and actually the next two really, are definitely ones that we should remember and practice using. The square function, similarly to our square root, where we knew that if you plugged in perfect squares, you could figure out how far you would go up. Well, square function is a little different. Now we can plug in any x value, but we know that the output is going to be those perfect squares. So what would we say? If we plug in 1, you go up 1 squared, or 1. If you plug in a 2, well then you go up 2 squared, or 4. Or you could go over 3 up 9, or over 4 up 16, etc., etc. That's what gives it its shape. Our last row down here, the cube function, is again kind of similar. We can plug in any x value we want, and we just want to cube whatever the input is. So 1, 1, or negative 1, negative 1. What if we plugged in 2? Well, then we would go up to 8, so 2, 8, or negative 2, 8. So again, what I care about right now is the shape. Probably, well, actually the next two are both a little crazy. The middle one here, number 8, the reciprocal function, we just call it that because it's 1 over x. And really what it is whatever you're inputting, you're taking the reciprocal of that value. So that's why there's these two really nice points at 1, 1 and negative 1, negative 1. Because if you do 1 over 1, you just get 1. Or if you do 1 over negative 1, you get negative 1. What happens, though, is you have to realize as you plug in bigger and bigger x values, right? As x goes up, the fraction gets smaller and smaller and smaller. So it gets closer and closer to y equals 0. So there's actually, oh, this isn't really showing up. There's actually a horizontal asymptote. Okay? We can also say, well, what if we get closer and closer to 0, right? If we're coming from the, let's talk about x equals 0, but from the positive side. So like if we plug in 1/2, well, what happens when we take the reciprocal of 1/2? It flips, so it becomes 2. Or if we plugged in 1/4, 1/4, the reciprocal of 1/4 is 4. So we have points like that. And as you get closer and closer to x equals 0, it goes higher and higher and higher up. It becomes larger and larger. So again, we have another asymptote, this one being a vertical asymptote. All right, and now the last one. One that I have not really used in quite a while, and honestly, we don't use this one a ton, but it's still good to know. And it's the greatest integer function. And basically what it is anywhere between 0 and 1, so like 0.000000001, what I want you to do is I want you to say, if you kind of take away that decimal, what integer are you left with? Well, you're left with 0. So the output would be 0. I can say the same thing if I move to the right, all the way to like 0.9999999999999. If I get rid of that whole decimal, what is the largest integer that I am left with? Well, it was 0.9999999. So my greatest integer is 0. The minute it hits 1, it jumps, right? Because now it does the same thing from 1 to 2, or 2 to 3, or 3 to 4. So that is a quick rundown of these graphs. And now what we're going to do is we're going to jump into rigid transformations. What we mean by rigid transformations is that the shape of the graph isn't really going to change, just the location. Okay, just the location. So the first shift that we're going to talk about is a horizontal translation. We will see, or what we need to understand, we're going to call this, and what we're looking for is we're looking for the C value. Okay, the C value tells us about the horizontal translation. The horizontal translation, or the C value, this is always going to be inside the function. And I'll explain a little bit more about that in a little bit. But it's inside the function. It's inside what the function is telling us to do. And it's opposite, okay? It's the opposite of what you think. Opposite of what it looks like. All right, so for example, if I want to shift my function to the left, it's going to look like this. It's going to be f of x plus c. If I want to shift to the right, then it will be x minus c. Hopefully you understand what I'm saying here when I'm talking about opposite of what it looks like. This says left, but this looks like to the right. Similarly, when I'm shifting to the right, I actually subtract the c value. All right, so let's look at some examples, and hopefully that will make a little more sense. X plus 2 squared. This is what I was talking about being inside the function. Do we see how this plus 2 is happening inside the square function? that means that the plus 2 is a horizontal translation. We'll get into what it would look like if it were not a horizontal translation in a little bit. So we look x plus 2. That means that we're shifting 2 units to the left because it's the opposite of what it looks like, which means my original point, which was at the origin 0, 0, is now 2 units to the left. And then whatever, I mean right now I don't completely care about points, but we do know with square functions that it will be 1, 1 and 2, 4, or vice versa going the other way, mirrored. Okay, so I could plot some points and I could nicely sketch my curve. All right, when we look at something like b, again, the minus 4 is inside the absolute value function. So this means that it is horizontal again, and it is minus 4, which means I am going 4 units to the right this time. Now, if I want, I can plot some extra points just to give it a little bit of shape, but I know that that is the general shape of my absolute value function. I can keep going. C, x minus 1 cubed. Okay, I have a cube function, and I am shifting 1 unit to the right. So I have that. And then again, if you remember, you can just kind of sketch the shape, or we know that if we plug in, or if we usually go over 1, it would be up 1 or back 1, down 1, just to give me a little bit of shape to my function. Last one, x plus 3, square root of x plus 3. Okay, so we have a square root function, and we have to shift 3 units to the left because it is adding. It is the opposite of what it looks like. Here I know that I would plug in 1, which would give me an output of 1. My next clean input would be 4 units, or 4 units to the right of the origin, and that would be an output of 2, and that kind of gives me a little bit of shape. Okay? So again, what I want you to understand, the c value, you would always see it inside of whatever function we are working with. Vertical translation is a little different. Okay, when we talk about the vertical translation, we're looking for a d value. And this one is going to be outside the function. Okay, outside the function. And guys, this one is exactly how it looks. Exactly how it looks. All right, so in this case, if I want to translate my graph up d units, well, I have to have f of x. Now remember, this d value is going to be outside the function, so I close the function, and then because it's exactly how it looks and I want to go up, I add d. Or, if I want to go down, it's f of x, and again, I'm going down, so it needs to be outside, but I subtract d. All right? What you will start to learn and hopefully understand quickly is that anything that has to do with horizontal translations will always be inside the function. Okay? Everything that has to do horizontally will be inside the function. And then, kind of conversely to that, anything that has to do with vertical shifts or vertical stretches or whatnot, anything that has to do with the y values will be outside the function. So let's take a look at a couple of these and then we will move forward. All right, down at the bottom here we have a square root function. We're going up 3 units, correct? This is outside, which means it is a vertical translation, and because it is plus 3, we do exactly what it says. So the square root of x going up 3, and then I could plot some more points, so 1, 1, 4, 2, and sketch. All right, x squared minus 4. All right, x squared minus 4. This is a square function or a quadratic, but I am now doing what? I'm going down 4 units, right? This is outside of the square function, which means it is a vertical translation. So 1, 2, 3, 4, and then if I want, I can plot some points. 2, 4, 1, 1, 2, 4, and I can nicely sketch my function. All right, let's take a look at this next one. This next one's a little crazy. I now am seeing I have a reciprocal function, reciprocal function, and I'm adding 2 to it outside of the function, which means this is a shift up 2. So I'm go here. This is my origin. Okay, this is my origin. Remember from our original, or from our page before, the origin is kind of where our asymptotes meet. Okay, so I know that I can put in my asymptotes right there, and I know that from this new origin I will have it a point 1, 1, or a point -1, -1, and then really I just want you to kind of sketch the curve. And sketch the curve. Doesn't have to be perfect right now. Okay? Lastly, absolute value. Again, my -1 is outside of the absolute value bars, or outside of the function itself. So I am going to know that this is a shift down of 1 unit, and again, absolute value is just that v, so I can do something like that. Okay? So that is horizontal and vertical translations. The next set of transformations that we're going to talk about are reflections. Okay, reflections. So, what I want you guys to notice real quick in these examples, is that negative technically inside? Is it being squared to, or is it outside of the square function? I would say outside. How about this next one? I'm taking the square root of x and then I'm making it negative. Is that negative inside or outside the function? Again, it's outside. Okay, so what I want you to take away here is that we are looking, and we will know that f of x is reflected over the x-axis when the function is multiplied by a negative. Multiplied by a negative. Alright, that's a mouthful. When the function is multiplied by a negative. Shorthand, you had f of x, well now you have negative f of x. Okay? This means that you have a flip or a reflection over the x-axis. Now hopefully this makes sense. We said on the page before that anything outside of the function itself, or outside of the square function or outside of the square root function, would have to do with y's. Well, when you reflect over the x-axis, what are you doing? You're changing the y value, right? You're changing the y value from positive to negative, or from negative to positive. So this is affecting the y. And that is exactly what we thought would happen because it is outside of the function. So let's take a look. We have negative x squared. X squared would normally look something like this, right? Oh, that's not very good. Well, when we reflect it over the x-axis, we know that we're just going to do what? Something like that. Again, points for right now, not my biggest concern. What about this next one, negative square root of x? Well, normally, if it was just square root of x, we'd have one of these. But now it's negative, so we flip it over the x-axis. Absolute value works the same. I could draw my original, not the best, but again, it gets the job done. Well, this one's going to flip over the x-axis because the negative is where? Outside of the absolute value bars. So boom and boom. And here we have a reciprocal. Reciprocal function would normally be one of these guys. Okay? But because there is a negative out in front, what's going to happen? Everything's going to flip over the x-axis. So now I have one of these guys. Oh man, I can do better. There we go. Something like that. Okay? All right. So again, If the negative is outside of the function, it is a flip over the x-axis, and that is what we thought would happen because that is a y change. That is a change in y. Well, what happens if the negative is inside the function? Something like this. Okay. F of x is going to be reflected over the y-axis because now the negative is inside of the function. Okay? And actually I should change this. Or add. Outside the function. Inside the function. And what did we say on the page before? Anything that is inside the function will have to change x values. Change it horizontally. If it's inside, it changes horizontally. So we take a look. We have a square root function. Normally, we would do what? We would have a square root function that looks like this. Well, because the negative is inside of the function, we have to flip it horizontally over the y-axis to something like that. All right. Oh, sorry, I didn't realize I was kind of off the page there. Okay. What about the next one? Absolute value, negative inside, which means it's going to be flipped horizontally or over the y-axis. Well, that's actually just going to be the same exact thing as the original, right? Hopefully that makes sense. The next one is actually the same, right? If my normal parabola or my normal square function would be a u. Well, when I flip it over the y-axis, I'm left with the same u. And lastly, this one's a little bit different. My normal function here, if I was just x cubed, would look something like this. But because I am multiplying by a negative inside of the function, it flips it horizontally or flips over the y-axis. So something like that. Okay? So real quick, before we go and finish up the last page, let's take a look at practicing writing these equations. Okay. We have to kind of figure out what transformation happened. If I look at A, letter A down here, hopefully we all agree that this is a parabola or it's a square function. So I know that I'm going to have f of x equals, so I know this is going to be an x squared. What happened here? This reflected over the x-axis, or all of the y values changed, correct? All of the y values flipped from positive to negative. Well, if I reflect over the x-axis, if it's reflected over the x-axis, that means that I multiplied the function by a negative, or -1 in this case. So I had a square function, but because it was reflected over the x-axis, I actually have negative x squared. How about this next one? This next one looks like a cube function. So f of x, it looks like it's a cube function. Now what happened to this one? It looks like it was shifted down. So we remember that because shifting down is a y transformation, that means that it's going to have to, or whatever we add or subtract or multiply by is going to have to be outside of the function. So again, we said it was x cubed, and because it's going down 3 units, we subtract 3. When we take a look at something like C, hopefully we agree this looks like a square root function. However, what has happened to it, it looks like it was flipped over the y-axis, or horizontally. So f of x equals, I think we're going to have a square root. What tells us that we flip over the x-axis, or sorry, over the y-axis, or flip horizontally? There has to be a negative inside of the function. Boom. Lastly, last one before we finish up the last page, let's see here. F of x, we know that this is absolute value. If we're shifting to the left, it looks like, that means that we are going to have to do what? Are we going to put something inside the function or outside? I hope you said inside, right? Because horizontal transformations always are inside the function. So I'm going to have my absolute value. I know this is going to be x. And if I shift 2 units to the left, you have to remember it's the opposite of what you think. So x plus 2. All right, almost done. Last thing, just some recognition, okay? This shouldn't take too long. Circle all the equations that indicate a horizontal shift left or right. So again, horizontal shift left or right has to be inside the function. And because it's a shift left or right, it's adding or subtracting. So we basically look. Are we adding or subtracting anything inside our function here? Absolutely, right? This is a square function and we're adding 4 inside the function. So this is definitely a horizontal shift. When we move on to b, what do we think here? No, right? We just have x cubed. We're adding outside of it, right? So this is no. We would not circle that one. C, square root function, subtracting 2 inside the function. Boom, absolutely. D, are we adding or subtracting anything inside the function here? No. E, same thing, right? We're adding 10, but it's not inside the square function. It's outside. It's outside. So nothing there. And then lastly, F, excuse me, absolutely, right? We have a cube function. We're adding 7. This adding 7 means I would shift left 7 units. All right, getting there. Now we're looking for vertical shift up or down. Vertical, or Y, means outside the function, and still shift means add, subtract. So we go through the same exact examples as before. Are we adding or subtracting anything outside the function? No. Are we adding, subtracting outside? Yep, sure are. Right? Are we adding or subtracting outside the function? No, we're adding inside, or sorry, subtracting inside. So that's a no. D is definitely a yes, right? We're subtracting 11 outside of the square root of 5x. E is also yes, right? We have 6x squared, and then we're adding 10. This would be a shift of 10 units up. And then we know that F, we are adding 7 inside, so this would be a horizontal shift, not a vertical. All right. Circle all equations that indicate a reflection over the x-axis. Over the x-axis means a y change, right? A y flip from positive to negative or from negative to positive, which means we're looking for a negative to be where? Outside. If the y is going to change, then we're looking for a negative outside the function. So we take a look. Negative 3x squared. Oh, I see a negative. Absolutely. When we look at b, I see this negative x, but that is not outside the function, so this is a no. Same thing with c, right? This is a square root function, but I'm multiplying by a negative inside the function, not outside, so that's a no. D is a definite yes, right? We are multiplying the square root of x plus 6, that entire function, by negative 1. So that is a yes. E, what do we think? We have a square function? Absolutely. This is definitely going to flip over the x-axis because we're multiplying by negative 8. And lastly, f of x. What do we think here? We see negative outside of the cube function, right? This is right here. Here's our function, and there is a negative outside of it. So what would we say? Yes. Lastly, reflection over the y-axis is a x change, which means we're looking for a negative inside the function. Let's go through these quickly because I know my video is ridiculously long here. F of x is equal to negative 3x squared. Let's see here. No, negative is outside the function, so let's cross that. Here my negative is inside the function, so that is a yes. Once again, square root function, negative is inside, this is a yes. Negative is outside, no. Negative is outside, no. And then f. Take a look at f with me for a second here. Again, here is my function. I have negative x plus 7 being cubed. So yeah, I see a negative inside the function. So this is. And this one, it's okay, and it shows that you can reflect over both. Alright, so I'm very sorry for this long video. I got a little bit carried away. Hopefully you guys can forgive me. I hope that you guys have a great day, and I'll see you next time.